Good morning, students. In the previous lecture regarding APT language, I have explained about the geometric statements. Once again, I will repeat the geometric statements now. Then we can go for the remaining statements like after geometric statements, we will have motion command statements, next post-process statements. In the end, we will have auxiliary statements. 4 types of statements are there regarding computer-aided part programming. Okay, so I will review the geometrical statement. First one, geometrical statements. Okay, so you know that one. The geometry means either point or line or plane, okay, etc. Right. So how we will define a point? How we will define a line? How we will define a plane? Those things I will explain now. After that one, we can move on to the motion statements. Okay, there are several motion statements. At the same time, there are several post-process statements and what are called auxiliary statements. Okay, and also I will explain 2 examples regarding application of these statements for generating 2 work parts. The first one is geometrical statements. Okay, right. In this one, so the syntax for geometric statement is like this. This is the syntax. Here symbol equal to geometry type / descriptive data. Where symbol means suppose if you want to define the point, we will specify a symbol. If you want to define a line, we will specify a symbol. Okay, similarly plane. So here the symbol, suppose geometry type is point. Here geometry type represents point, line or plane. And descriptive data, for point coordinates, XY coordinates, for line conditions, for plane conditions. Okay, we will represent like this. This is the syntax. This is the syntax for defining a geometry using APT language. Okay, right. Now, for example, here he has given, suppose for point, how we will define the point by using APT language. So point 1, consider P1 here. P1 represents symbol. Okay, next point. So geometry type is point. Okay, / next x coordinate 5, y coordinate 4, z coordinate 0. 5, 4, 0. Okay, so like this we can define a point directly. You can define a point P1 equal to point / 5, 4, 0. Right. So you can represent different coordinates, not only 5, 4, 0. You can represent any x value, any y value, any z value. That depends upon the work part we are going to do the measuring operation. Okay, right. So this is for definition of the point. Now suppose I want to define a line. This is over. Suppose if I want to define a line. Okay, so here first what is it? For point, line or plane, the description is symbol equal to. Here for line symbol is L3. L3 is the symbol. Next one. Geometry type is line. And P3, one end point. P4, other end point. Okay, so line L3 equal to line / P3, P4. That means here I have been defining a line, okay, by using 2 endpoints. One endpoint is P3, other endpoint is P4. Okay, right. So before writing this statement, we have to define P3 and P4 above this L3. Suppose if you define P3 and P4, then we will go for the definition of the line L3 passing through P3 and P4. Our endpoints as P3 and P4. Okay, right. This is one way of defining the line. Okay, right. Next another way is L4. Okay, how we will define line? Another line. Okay, L4 equal to line. Descriptive geometry type is line. Next one, P5, point 5. That means P5 means the line passing through P5 and parallel to parallel L, comma L3. L3 means L3 line parallel, it must be parallel to the line L3 and passing through the point P5. Okay, like this we can define another way of depending upon the data given, we can define the straight line in another way. Okay, so these are the two methods generally we will define a straight line. Next we will go for the plane. Okay, so plane also there are two methods. In one method, plane one PL, symbol is PL. So here I am again telling you. So no need to specify P1, L1, L2, PL1 like this. That is our choice. Symbol is our choice. Next geometry type is syntax. According to syntax we have to follow. Geometry type is plane slash passing through P1, P4, P5. That means 3 points we require for plane. Suppose if we have 3 points, we can define a plane passing through, or the plane which contains those 3 points. That is, here what are the points I have considered? P1, P4 and P5. This is one way of defining the plane 1. Or another one is plane 2. This is another way of defining a plane. Okay, how we will define here? Again PL2 equal to plane. This is the geometric type slash next one P2. P2 means passing through the point P2. P2 means point. So passing through the point P2 parallel to plane 1. Parallel comma plane 1. Syntax you have to remember. Here parallel. So plane, line, point. This English words syntax you have to remember. So here the other way of defining the plane 2 is plane slash passing through P2 parallel to plane 1. Okay, so there are two methods I have been explained about the definition, defining the plane. Next one is circle. Go for the circle. You know that one. Circle data in simple form. Suppose if we have center and radius of the circle, we can define the circle. Okay, right. So C1 equal to, this is the symbol. Next, circle is a geometric type. This is the APT language. Next one, slash, again center. Suppose if you write center, comma, immediately we have to specify the point, center point. That is P1. Here I have taken P1, comma, radius, comma, what is the radius? Here I have given radius 5. You can give any other radius. So circle definition. C1 equal to circle slash center P1 radius 5.5. That's it. Okay, this is about defining a circle. Okay, by using this form. Right. So these are the geometric statements. Geometric statements means defining the different geometries. Defining the different geometries like point, line and plane. Right. For example, here he has given one example. Suppose if we consider this part, this is x line and x-axis, this one is y-axis and this one is planar object. Okay, right. So here, how is this one formed here? Here, suppose if you observe this entire diagram, divisions are there along x-axis, divisions are there along y-axis, and okay, P2 is the at the intersection point. P2 is the intersection point of x and y axis. That means its coordinates are 0, 0, 0. Origin is the P2. Next P0 I have defined here. P2 okay. P1. P0 after P0 P1 I have defined there, and P2 defined and P3 defined. This is the P3, and next one is P4 defined. Okay, right. After that one I have defined the circular arc C1. And the lines. This is the line L1 and this one is the line L2 and this one is the line L3. L2, L3 and L1. Okay. So this entire part consists of what are the geometries? One is points, 4 points. Okay. 4 or 5 points. One is target point. So that is not belonging to the geometry part. So remove that one. Next go for the center of the circular arc P1. Next P2, origin, and P3, circular arc starting point, and P4, the tangent endpoint P4. The 4 points and straight lines L1, L2 and L3. 3 straight lines and one circular arc. One circular arc. What is the center of this circular arc? P1. What is the starting point of the circular arc? P3. What is the ending point? So that you can define here. After that one, tangent to the circle, and that will meet at the point 24. Okay. Right. Right. Okay. So like this you can define the different points. Okay. Where is it? Yes. Okay. Anyway, right. So this is the work part we have. It has center hole. Hole center is there, and this is another center. Okay. These for drilling. So here we have to drill the hole here and here. Okay. This is a hole. This is a hole, and straight lines and circular arc and points that constitute the entire part here. So, again, now what is the point? How we will define the point P naught? How we will define the point P naught? Okay, right. P naught equal to, you know the syntax P naught, that is symbol equal to point slash 0 minus 1.00. That means 0 means x value 0, minus 1 means y value minus 1, and from 0, P2 దగ్గర 0 ఉంటుంది, then P naught వచ్చేసరికి minus 1. Next 0, z value is 0. Okay, right. Next P1. How we will define the P1? P1, center of the circle, coordinates are 6, coordinates are 6, 1.125. 1.125. Okay, comma 0, z value is 0 for P1. So definition of P1 is over. Next P2, that you have to tell. P2 is the origin. So point slash origin means x coordinate 0, y coordinate 0, z coordinate 0. That means 0, 0, 0. That C is over. Next point P3. This one is the point P3. What are the coordinates? S coordinates is 6, y is 0, z is 0. Next point P4. P4. What are the coordinates for P4? Okay, 1.75. 1.75 x coordinate, 4.5 y coordinate, z is 0. Next, so up to now 4 or 5 points I have defined. P0, P1, P2, P3, P4. Next I will go for the circular arc. For this one C1. C1 is the circular arc. What is the center of the circular arc? P1. So circle slash center P1. Next one is radius. What is the radius of the circle? Okay, 1.125. Radius of the circle is 1.125. Right. Center P1, radius 1.125. That defines the circular arc. Next one is L2, line 2. This one is line 2. This is tangent to circle 1 in left side tangent. This one is the left side of tangent. So here line 2 is defined like this. Line passing through P4. That's why P4, comma, left tan to C1. Passing through P4, left tan to. Tan 2 means tangent to the circular arc C1. That left, comma, tan 2, comma, C1. That is the definition of the point line 2. Next one is L3. So L3 passing through P2 and P4. That what I have written. Line one endpoint P2, other endpoint P4. P2 and P4. That is over. Plane. This entire plane we have to define once again. How we will define this plane? PL1. Let it be first plane. PL1 equal to geometry type is plane slash it is passing through P2, P3, P4. 3 points. We know that one. You can define the plane by using 3 points. Those 3 points are P2, P3, P4. That what he has represented here. So this is about the geometric statements are defining the given geometric. Defining the given object using geometric statements. Okay, that we can using APT language. So like this you can define this one. So next one, motion statements. Here I will explain in the next slide. Okay, right. So here we have all the motion statements are not here. I will explain in the next slide. Okay, suppose for this one, again I want to define the geometric statements for this work part. How we will define? So look into this one, all of you. I will come this side. So all of you observe this one, this diagram, and dimensions and holes and shape of the given work part. Okay, right. This is a rectangular work part defined in XY plane, and this point is the origin point. Okay, right. So now, what is the length of the this rectangular part? Length is 3.5, and height is very high. So height is I think 1.5, 2, and for this one 3, and no 3, 2.5, right? So 3.5, 2.5. After that one, okay, right. Here is one hole. First hole is this one, second hole is this one, third hole is this one. These 3 holes we have to do. Okay, right. Next, starting point is, clearance point is this one, spindle. This is minus coordinates of this point is spindle initial location. Okay, -1, height is 3. Okay, height is 3. Z is 0. Z is 0. So minus x1 is the x value, 3 is the y value, z is 0. 0. Like this. So this is the starting point of the that is what is called spindle, and this is the rectangular part of dimension 3.5 and 2.5. Next, this one is the initial circle. Okay, one. Second circle is this one. Third circle is this one. So for this one, how we will define this work part is in geometric statements. Or what are the geometric statements regarding in Apt language for this work part? Okay, first go for the points. P1. Where is P1? Here we will have we require P1. So if we have coordinates 1, 2, 0. Where is 1? This one. 2 is this one. So P1 means center of the hole. 1. First hole center. So x coordinate is 1, y coordinate is 2, z coordinate is 3. That is what I have represented. 1, 2, 0. Next, another point is P2. P2 is the center of the second hole. Okay, for this one, 1 is the first x direction. In x direction, 1, this is the x value. Next one is y value also 1. Next, z value 0. 1, 1, 0. P2. Next, P3. P3 is center of the third hole. Coordinates 3.5, 2, 0. 3.5, sorry, 1.5, right, 1.5, 0. Next, P0. P0 is nothing but starting point of the spindle. So here I have told you, this is the starting point. That means x value is minus 1.0. Next one is y value is 3. Y value is 3. Spindle. This is the spindle initial location. The dark black spot represents starting position of the spindle. Point -1, 3, -1, 3 and 2. Z value also he has given, but in the plane diagram, so it is impossible to represent z coordinate. Third dimension representation in plane value is impossible. That's why there is no plane value. But here in the statements you can write the z coordinate for that point P0. Okay, so like this you can define this one geometry statements for this one part. Okay, right. Next one is motion statements. How we are going to drill the holes here? How we are going to drill these holes here? Okay, right. So first one from point P2. So what is the initial position of the spindle? P0. P0 is the initial. So from P0, from /P0. That means that from the target point to where it has to move, where it has to drill the hole. From this point to this point, center of the hole 1, the spindle along with the drill bit, it has to move directly to this point. So for this direct motion of the spindle which contains the drill bit, we will use this syntax. Go to is just rapid movement of the drill bit or cutting tool or spindle, rapid movement. Wherever it is there, it may follow this path or straight path, whatever it may be. So in different paths, it has to come to this point, first center of this first hole to this first hole rapidly from target to this point. Rapid movement, we will use the syntax go to / P1, center of this point is P1. Okay, P1, it will go to P1. So now after this motion, what happens? The drill bit lies at this position, center of the hole one. Then what is the next motion? It has to drill a hole at that location to the work part. That means we require z coordinate. We have to specify the z coordinate for making the hole. For that one, we need the thickness of the work part. Let the thickness of the work part is 1. Let the thickness of the work part is 1. 1 means, okay, so this go delta means incremental value of the cutter moment or drill bit moment, incremental value. Delta means incremental value. Go delta, DLTA. That symbol, this note, go DLTA is must you have to use. That is the syntax for the incremental motion of the work part. / 0, 0, minus 1.0. Okay, so go delta, that means x direction there will be no movement, y direction there is no movement, only z direction it has to move through the thickness of the work part. That means thickness of the work part is 1, hence making a hole means minus 1.0. Minus 1.0 if you specify, then the drill bit will move to the minus 1.0 and it will make a hole here. Okay, next go delta. So after making a hole, they have to come back to the surface of the work part. So again minus 1 to plus 1, it has to come up. So the drill bit has to come up. That means it has to move away from the hole. Right. For that one, plus 1 we will use. Minus 1 means making the hole. Plus 1 means retracting from the hole after making the hole. Right. So go delta, increment value is plus 1. Then it will come to the surface of the work part. This is making one value. Okay, one hole. Suppose you want to make another hole. For the second hole, center is P2. So go to, from this location, go to P2, center of the second hole. Next, okay, go delta. Go delta means increment value. That means it has to go to the minus 1.0. That means minus 1 mm or any other unit and make the hole through 1 mm thickness. Okay, or 1 thickness. Next for go delta, minus 1, after minus 1, plus 1. Similarly for this point, path also. Third point also, P3, let it be center is P3. So go to P3, next go delta minus 1.0, 0, 0, minus 1.0. And that means z coordinate value, making the hole and come back to plus 1, minus 1, plus 1. So here also another hole is made. That means here we will have, okay, third hole is represented here. Third hole is done here. So at the tip of the drill bit is on the surface. Now where we have to move? After completion of these three tasks, 3 holes, making the 3 holes, it has to go to the initial position, that is P0. It has to go to the P0. That means spindle location, minus 1.030. And so go to P0. This is P0, go to P0. Rapid movement from here to there, rapid traverse of work, drill bit. So like this we can make this work part also. So I have given 2 examples. Okay, right. For motion statements. So here what are the statements we are getting in motion statements? Go DLTA. Go DLTA. Using these two, go to is used for rapid traversal. Go delta is the incremental movement of the work part for making the holes. Okay, so using these 2 statements, 2 or 3 statements. Okay, using these 3 statements, we can make the holes. Drilling operation can complete. Okay, right. So next one. not required this one. Contouring motions. Right. These points, contouring motions, till now we have only what is called interpolation movements. Interpolation movement, that is rapid movement, rapid travels, and go incremental movement, go DLTA. These two motions we have learned. Now, those things are used for making general objects. Okay, suppose if there is a milling operation or drill bit or cutting tool, not machine tool. Cutting tool has to move in a different curved path in a specific direction and removing the material for the that is a general way. In general way, it has to move and it has to remove the material. For that, those operations are called contouring operations, and these operations are performed by specifying different surfaces. By specifying different surfaces, one is bottom of the cutting tool, one is left side, and another one is ending point of the cutting tool. These three surfaces, if you specify, and then we will make the cutting tool to follow these three surfaces always, then we can do the contouring operation. That I will explain in the next class. Okay, for this class, okay, now I have completed the just rapid traversal and incremental movement to make the holes, okay, and to make the work part, different circular work part contains rectangular surface, rectangular shape, and work part contains circular arc and other things. Okay, now we can go for the contouring motions for different other operation. Okay, so for this lecture, up to now what we learned is concluded. Next we can go for the contouring operation in the next class. Okay, thank you very much. The previous lecture we have learned about the rapid motion statements and geometric statements. Regarding motion statements, I have explained the rapid traversal and incremental movement of the cutting tool by taking two examples. Next one is, okay, for generating contour shapes, that means irregular shapes. In that case, we have to continuously guide the cutting tool. Okay, to get the required shape of the work part. Okay, right. So for that one, in this APT language, they will explain by using three types of surfaces. One surface is drive surface, second one is check surface, second one is part surface, third one is check surface. So how they will be, we will imagine like that, these three surfaces, and we will define in the APT language. Then we will go for the movement of the work part according to the definition of the drive surface, part surface, and the check surface. Okay. Now, so for this one, here we have a diagram. So all of you observe this diagram. In this diagram, this surface is called drive surface. Okay. This surface is part surface. This surface is part surface.
This is Kotla. The pencil chain.
Right. Okay. This one is a part surface. This one is a dry surface.
Color match pen.
This one is part surface. This one is dry surface, and this one is check surface. This one is dry. This one is check surface, and this one is cutting tool. And cutting tool movement is in this direction. Arrow mark represents the cutting tool direction. Okay, right. So if you observe this cutting tool, at this surface we will have dry surface at this location, and at the bottom of this cutting tool we have part surface. Okay, this is the work part. Okay, next, where the cutter movement will be and the cutter movement will be end at the check surface after passing the check surface, or just touching check surface, or the center of the cutting tool may reach the check surface, or it will, the entire cutting tool will just pass the check surface. There are three cases are there. Those three cases for check surface, I will explain. Okay, now, so this is why, how we will define the, how we will guide the cutting tool. Okay, for contouring motions, One is by using dry surface, hard surface, and check surface. Okay, right. So next slide. Already I told you. Okay, so go left means around the dry surface the work part will move. Okay, and go right. Around the dry surface, right side the cutting tool will move. Go forward and go backward, forward and backward. Similarly, go up and go down, go up and go down. These six are cutting tool movements in APT language. Okay, go left, go right, go forward, go backward, go back, go up and go down. Or part that cutting tool movement in upward direction, downward direction, left and right, forward and backward. Okay, next, coming to this diagram, to on past, I already told you where the cutter has to stop when it reaches the check surface. Okay, right. Dry surface, suppose if you view the diagram from the top, okay, we will have a circle regarding the cutting tool. Here is a circle regarding the cutting tool. Its movement is like this, movement direction, this arrow mark represents movement direction. This one is dry surface. If you view from top, it will appear like a line. Okay, this is the work part. Okay, right. Now, so the cutting tool surface will tangent to the dry surface is tangent to the cutting tool surface. Then it will move in the forward direction or right direction, in the right side direction. Suppose if we write 2 in the syntax for final position of the work part, the cutting tool, final position of cutting tool. So then the cutting tool will just, surface will just touch the check surface. Then it will stop. Okay, so right, arm means the cutting tool will, the center of the cutting tool will, okay, just touches the check surface. That is on the check surface, And next, past means the entire cutting tool has to pass the check surface. This one is the check. This line represents check surface. Okay, so entire surface just passes the check surface. Then after passing the this check surface, okay, the cutting tool will touch the check surface in the left direction. So there are 3 cases where we have to stop the cutting tool movement around the dry surface by using check surface. One is to, second one is on, third one is past. Right. So for this dry surface continuously guide the cutting tool movement. Here I have shown a straight line. It may be a curved line. It may be a combination of straight line and curved line, or it may be a free form surface. So whatever it may be, the shape of the cutting dry surface, the cutting tool will follow that surface, that part. The cutting tool will follow that part. Okay, right. So next one. Post-process statements. So post-process statements are here. Coolant on and off. On or off. We have to write. End. Put down. Feed rate slash. Here we have to specify the feed rate. Okay. Machine on and off or off. On or off. Rapid means rapid traversal. Spindle on or off. On or off. Turret same on or off. Like this we have different auxiliary statements. What is the post-process statements? After completion of machining process, okay, we can do this. Or during the machining process, post-process, during the machining operations, we can specify these things. Okay, right, these syntaxes required. Next, auxiliary statements. Auxiliary statements means for the movement of the cutting tool, what are the auxiliary helping statements? Or those statements will help us to calculate for calculating the offset and other things. So if you observe these things, here clear print, okay. Next one is internal tolerance. Intolerance means internal tolerance. Here we have to say the value. And here out tolerance, external tolerance. Part number, cutter, is a drill bit or a miller or whatever it may be. Finish, that means stopping the that machine material removing operations. Okay, these are the auxiliary statements. Okay, right. So with this, we have completed the what is called computer aided part programming using APT language. Computer aided part programming using APT language for different what are called work parts with different geometries, different hole locations and other things. Okay, right. In the next class, I will explain the manual part programming with one example. Then we after that one computer aided what is called these are different types of CNC machines. Computer numerical control, direct numerical control and conventional numerical control. Comparison I will explain. Then we can within 2 classes we can conclude this what is called coding. Right. Thank you very much for that.